Welcome to the Deep Dive. We're here to help you navigate the flood of information out there.
Yeah, it's a lot.
It is. You want to be informed, understand things, but who has the time to sift through everything? That's kind of our job.
And today, we're diving into a real classic, actually. How to Lie with Statistics by Daryl Huff. Still so relevant.
Totally. Daryl Huff, that's he born 1913, background in psychology, worked as an editor, wrote a few things.
Including How to Take a Chance, which sounds interesting, too.
Right. But How to Lie with Statistics from 54 with those great Mel Kalman pictures added later. That's our focus.
It's brilliant because it's not really for statisticians, is it? It's for, well, everyone else who bumps into numbers every day.
Exactly. And Huff's whole point is that numbers, even honest ones, can paint a misleading picture if you're not careful.
You have to know the tricks, basically. Self-defense with stats.
Yeah, even the cover kind of hints at it, doesn't it? With the cartoon and 4.56% of the time.
Mm-hmm. Very tongue-in-cheek. Suggests truth is a bit slippery.
Okay, so let's get into it. Huff breaks down all these ways stats get twisted.
He really does. And we're going to hit some key chapters today. We'll look at biased samples, what average really means or doesn't mean.
What's missing from the numbers?
Yeah, the missing figures bit. And those misleading graphs, the gee-whiz ones, he calls them.
Oh, yeah. And the one-dimensional pictures, the semi-attached figure.
Post hoc, the cause and effect trap.
Right, post hoc rides again.
Yeah.
And finally, statisticulation, love that word, and how to fight back, how to question stats. Ready?
Let's do it. So first up is the sample with the built-in bias. It's amazing how easily you can go wrong if your sample isn't, well, representative.
It's like that analogy he uses, right? The barrel of beans, red and white.
Exactly.
If you just scoop out a handful from the top and it happens to be mostly red, you can't just say the whole barrel is mostly red.
No way. That little scoop doesn't tell you the whole story. Your sample has to actually reflect the whole barrel or the whole population you're studying.
Makes sense.
And he gives some great examples, like imagine mailing out a survey asking people if they like answering surveys.
Right. Who's going to send that back?
Probably people who feel really strongly, maybe negatively, so your results are skewed from the start. You're not hearing from the average person.
Or that poll the Herald did about Catholic to Protestant conversions.
Yeah, surveying the clergy.
Which sounds official, but interviewing clergy in just a few places and then trying to blow that up to a national figure.
It's super unreliable. Huff points out the real number could have been way, way lower than the 4 million they claimed. The method was just flawed.
It really shows how the how matters, doesn't it?
Absolutely. Then there's that famous example of the average Yale man, class of 24, earning, what was it, $25,111 a year.
Which sounded like a huge amount back then.
Definitely. But Huff asks, okay, who wasn't included in that average?
Right. They only used alumni whose addresses they actually had.
So anyone who maybe wasn't doing so well, moved around, lost touch, they're just not in the sample.
Skews it towards the successful ones.
Plus, people might, puff up their income a bit when asked. Self-reporting bias.
So that big average number,
Mm-hmm.
maybe not so representative of the whole class.
Probably not. It reminds you to always ask, who exactly is in this average?
It's like a huge literary digest poll blender in 1936. Predicted Landon would beat Roosevelt.
Oh, yeah, a classic. Sent out millions of ballots.
But who got them? People with phones, people who subscribed to magazines.
Basically wealthier folks back then who tended to vote Republican.
And the actual voters. Right. A much broader group who went heavily for Roosevelt.
Yeah.
Big miss.
A perfect example of a non-representative sample leading you completely astray. So Huff talks about the ideal, the random sample.
Where everyone in the group you're studying has an equal chance of being picked.
Right. Sounds simple, but doing it properly is actually really hard and expensive.
Which is why they often use stratified random sampling.
Exactly. You divide the population into relevant groups first, like age groups, income levels, whatever makes sense. Then you take random samples from within each of those groups, or strata. The idea is to make sure you get a mix that reflects the overall population structure.
More efficient, maybe, but still tricky.
It can be.
Yeah.
Huff notes bias can creep in just deciding how to stratify. Like, how do you accurately classify someone's race or occupation? It involves judgment calls.
And then there's just convenience, like polling door to door during the day.
Right. Who's home? Mostly people who aren't working traditional 9 to 5 jobs.
So you miss a whole chunk of the population right there. Your sample is biased towards stay-at-homes.
Exactly. And Huff says all these little biases, even unintentional ones, can add up. They can make polls consistently lean one way or another.
So the big takeaway on samples is be skeptical, ask where the data came from, who was included, who was left out.
If the sample's dodgy, the conclusions probably are too.
Okay, good stuff. Let's move on to the next chapter. The well-chosen average. Average seems simple, but maybe not.
Yeah, you'd think so, but average is one of those words that can hide a lot. Huff points out there isn't just one average. There's the mean, the median, and the mode.
Okay, break those down. Mean is the one we usually think of. Add everything up, divide by the number of things.
That's the one, the arithmetic mean. But the problem is it's really sensitive to extreme values outliers.
Like your neighborhood income example. Couple of millionaires move in.
Exactly. Their huge incomes pull the mean income way up, even if most people in the neighborhood earn much less.
So the mean doesn't really reflect what's typical for most residents.
Not always. That's where the median can be more useful.
That's the middle value, right? If you line everyone up by income, the person's smack in the middle.
Precisely. It's less affected by those really high or really low incomes at the ends. So in that neighborhood, the median income might be much lower and give a better picture of the central tendency.
Gotcha. And the mode?
The mode is just the value that shows up most often. So if a lot of people in that neighborhood earn, say, $50,000, then $50,000 would be the mode.
Okay. So mean median mode.
Mm-hmm.
They can tell different stories from the same data.
Hugely different. Huff uses that example of a small business. 3 partners making big bucks. 90 employees making modest wages.
Right.
If you calculate the mean wage, including the partners, it might look pretty good.
But it hides the fact that most workers earn way less.
Exactly. The median wage, or maybe even the mode, would give a much more realistic picture for the typical employee.
So someone could report the average wage using the mean to make the company look good, even if it's misleading for the workers.
That's the danger. Depending on which average you choose to highlight, you can spin the data quite effectively.
And he also mentions things like average family income. Sounds straightforward, but...
But what's a family? How is income distributed? Is it the mean? Median? Without that context, the number itself isn't that informative.
So whenever we hear average, we need to pause.
Yeah. Ask. Average which? Mean, median, or mode? And what else do I need to know to understand this number?
Good advice.
Yeah.
Okay, Chapter 3 in Huff's Guide to Statistical Mischief. The little figures that are not there. This is about missing info, right?
Exactly. Sometimes what's not said is the most important part. Small sample sizes are a big one here.
Like in advertising claims?
Oh, definitely. Huff talks about, say, a toothpaste ad claiming it reduced cavities by 23%. Sounds precise.
Yeah.
But then you find out the test was done on, like, 12 people. Or 6.
That's tiny. The results could just be random chance, couldn't they?
Absolutely. With such small numbers, the results aren't statistically significant. You can't reliably say the toothpaste caused the reduction based on that.
So always look for the sample size. If it's not mentioned, or if it's really small, be suspicious.
Very suspicious. And Huff brings up the polio vaccine trials, too. Early on, some reports focused on the number of vaccinated kids who still got polio.
Which sounds bad.
It does. But what was missing? A proper comparison group. How many unvaccinated kids got polio during the same period? You need that baseline, that control group, to know if the vaccine is actually making a difference.
Context is everything.
It is. And related to that is the degree of significance. Even if something is, say, 95% effective.
There's still that 5% chance it doesn't work.
Right.
Or the result was just chance.
Right. And 5% might sound small, but depending on what you're talking about, it could still represent a lot of cases or failures. It's not a guarantee.
And averages again.
Yeah.
They can hide missing information too, right? Like the range of data.
Totally. The average family size might be, what, 3-point-something people? But that single number tells you nothing about how many families have 1 person, 2 people, or 6 people.
It masks the variation.
Exactly. The average might be technically correct, but useless for understanding the actual distribution.
He applies this to child development too, doesn't he? The idea of normal milestones.
Yeah, saying it's normal for a baby to walk at, say, 12 months. That can stress parents out if their kid walks at 10 months or 14 months.
Because normal implies a single point, but really there's a range of typical development.
Right. What's missing is that information about the typical range.
And in news reports, seeing just one number for a new development.
Without comparison to previous data or context, it's hard to know if that number is high, low, or just noise. It needs those missing figures for comparison.
So the theme here is look for what's not being shown. Sample size, control groups, range, comparisons. That missing information is often key.
Definitely. Always ask, what else do I need to know?
Okay, moving on to visual tricks. The gee whiz graph. We've all seen these, the ones that make tiny changes look like earth-shattering events.
Oh, yeah. Graphs are powerful because they're visual, but they're also really easy to manipulate.
What's the most common trick Huff points out?
Probably truncating the axis, cutting off the bottom part.
So the vertical axis doesn't start at 0.
Exactly. Let's say you're showing national income and it went up by maybe 10% over a year. If your graph's vertical axis starts near the lowest point instead of at 0.
That 10% jump suddenly looks like a massive spike climbing way up the graph.
Precisely. The visual impression is completely out of proportion to the actual percentage change. Same data, vastly different impact.
Sneaky.
Very. And you can also mess with the scale. Stretching the vertical axis and squishing the horizontal one makes things look steeper.
Or do the opposite to make a rise look flatter.
Yep. By adjusting the ratio between the height and width of the graph, you can make almost any trend look dramatic or insignificant, whatever suits your purpose.
Advertisers must love this.
They do. Huff mentions a gas company ad where they wanted to show a decrease in cost, but they made the graph visually minimize the drop. And conversely, he shows a graph where a fairly stable government payroll was made to look like it was rocketing upwards just by chopping the bottom off the graph and stretching the scale.
So our eyes focus on the slope, and the graph maker controls how steep that slope looks.
That's the key insight. Don't just glance at the shape of the line. Check the axes. Where do they start? What are the increments? Is the scale appropriate?
Good checklist. Always read the labels, not just the picture.
Absolutely. And sticking with visual tricks, there's the one-dimensional picture.
This is where they use little drawings instead of bars on a graph?
Yeah, like using pictures of money bags to show differences in wages, or cows to show milk production.
Okay, so what's the problem there?
The problem is how we perceive size. Let's say average Joe's wage doubles. To show this, you draw a second money bag that's twice as tall as the first one.
Seems reasonable.
But to make it look right, you probably also draw it twice as wide. So the second money bag isn't just twice as tall, it covers 4 times the area on the page.
Oh, right, because area is height times width.
Exactly, and our brains tend to interpret that area, or even the implied volume, as the quantity. So a doubling of wages visually looks like a quadrupling, or even, thinking volumetrically, an 8-fold increase.
Wow, that's a huge distortion.
It is. Huff uses that Rotundia versus England wage comparison with the money bags to show exactly this effect.
And the steel furnaces.
Same idea, showing a 50% increase in steel capacity by drawing a furnace that's taller. But because it's a 2D picture, the area increases much more than 50%, exaggerating the growth.
Like the milk cows from 1860 versus 1936. Making the later cow taller makes it look massively bigger overall.
Way more than the actual increase in milk production it's supposed to represent.
So the lesson is, beware of pictograms where size is used to show quantity. Our eyes can easily be fooled by the scaling of area or volume.
Yep. Look at the numbers they represent, not just the size of the picture. It's a subtle but effective deception.
Okay, moving from visual to logical tricks. The semi-attached figure. What's that about?
This is where you use a statistic that sounds relevant but actually has little or no logical connection to the point you're trying to make.
An irrelevant fact dressed up to look important.
Pretty much. Huff's classic example is the disinfectant ad. Kills 31,108 germs in a test tube in 11 seconds.
Sounds impressive. Very specific.
Very. But what's the semi-attached part? Does killing germs in a lab dish have anything to do with curing your cold?
Probably not directly, no.
The ad implies it does, but provides no proof of that connection. The germ-killing number is attached to the product, but not really attached to the benefit claimed, curing colds.
It's a leap in logic hidden by a number.
Exactly, or that claim. 27% of eminent physicians surveyed smoke throaties.
Okay. And Jen?
And nothing. So what if they do? It doesn't mean 30s are healthy or that doctors recommend them or anything relevant to the quality of the cigarette. It just attaches the prestige of eminent physicians to the brand.
It's purely association.
Purely. Think about accident statistics, too. You might hear deaths on trains went up 10% last year.
Sounds scary. Makes you think twice about taking the train.
Right. But what's missing? How does that compare to deaths in cars or planes? What about the total number of miles traveled by train? Did that go up too?
Without that context, the 10% figure is semi-attached to the idea of train safety, but it doesn't actually prove trains became less safe overall.
Precisely. Or seeing a percentage return on investment without knowing the initial amount or the time period. A 50% return sounds great, but if it was 50% on $10 over 10 years.
It's basically meaningless.
Exactly. Or comparing death rates between, say, the Navy and the general population of a city during wartime. The populations are completely different in age, health, exposure to risk. You can't draw simple conclusions.
So with semi-attached figures, we need to ask, is this statistic really evidence for the claim being made? Or is it just noise designed to impress or distract?
That's the core question. What's the actual logical link? Is it strong or just semi-attached?
Got it. Okay, next logical pitfall. Post hoc rides again.
Post hoc ergo propter hoc. Latin for after this, therefore because of this.
The assumption that if B happens after A, then A must have caused B correlation equals causation.
Which is a huge fallacy, as Hoff points out. Just because two things happen together or one after the other doesn't mean one caused the other.
He uses that funny example about storks and babies, right?
Yeah, finding a correlation between the number of storks' nests on rooftops and the number of babies born in those houses in some European villages.
Obviously, the storks aren't delivering the babies.
Obviously. There's a third factor. Bigger houses are more likely to have room for both large families and suitable chimneys for storks' nests. The correlation is real, but the causation is spurious.
So look for those hidden third factors.
Always. He talks about the correlation often found between smoking and lower college grades.
People assume smoking makes you dumb or lazy.
That's the easy assumption. But maybe students who are more inclined to smoke are also more inclined to socialize more and study less. Or maybe there's another personality trait linked to both. Smoking itself might not be the direct cause of the lower grades.
The relationship is more complex.
Much more complex. And sometimes correlations just happen by pure chance, especially if you look at enough data.
Like finding a link between ice cream sales and crime rates.
Exactly. Both tend to go up in the summer, but ice cream doesn't cause crime. The third factor is warm weather.
I've had that absurd one. Ministers' salaries in Massachusetts and the price of rum in Havana.
Yeah, just a nonsense correlation that probably showed up in some data set somewhere. Means absolutely nothing.
Or June weddings and suicide rates.
There might be a statistical blip sometimes, but it's incredibly unlikely one causes the other. Maybe other seasonal factors are involved. The point is, correlation isn't proof.
Even when it seems logical, like education and income.
Even then, yes, there's a strong correlation, but does education directly cause higher income in all cases? Or do factors like family background, natural ability, ambition, and choice of field play huge roles? It's not a simple A causes B equation.
Causation is hard to prove.
Very hard. He even mentions that weird finding in the New Hebrides. Good health correlated with having lice.
Oh, seriously.
Turned out, healthy people didn't run fevers, and lice thrive better on cooler bodies. So good health allowed lice to flourish. The lice weren't causing the good health.
Wow, okay. So the takeaway is correlation is not causation. Always question if A really caused B or if there's another explanation.
Exactly. Be deeply skeptical of simple cause and effect claims based only on correlation.
Right, which brings us nicely to the chapter that sums it all up. How to statisticulate.
Statisticulate, great word.
It really is. It's the art of using stats not to inform, but to deliberately manipulate and mislead.
Right. That's the essence of it. Using all the tricks we've talked about, and maybe a few more, to push an agenda or sell something.
What are some examples of statisticulation he gives?
Well, he talks about maps again. Shading a map based on total income in different states, for instance.
Makes populous states look richer even if their per capita income isn't that high.
Exactly. It creates a misleading visual about where wealth is concentrated just by choosing the wrong metric total versus per capita. It's choosing the statistic that tells the story you want.
Like choosing the mean or median average to make charitable donations look bigger or smaller. He mentioned the Russell Sage Foundation.
Yep, same principle. Pick the average that supports your narrative. He also talks about using fake precision.
Like saying someone sleeps 7.831 hours.
Yeah. That .831 suggests incredible accuracy that's just not realistic for measuring sleep. It lends a false air of scientific rigor.
And percentages can be used to statisticulate, too.
Oh, definitely.
Huh.
You can calculate percentages in confusing ways, like that complex rate of surplus value example, to obscure what's really going on financially.
Or those massive discount percentages in stores.
Based on a hugely inflated original price nobody ever paid, the percentage sounds amazing, but the actual saving might be small.
And index numbers, like the Consumer Price Index.
Those can be manipulated too. Huff shows how just changing the base year you use for comparison can make the change in prices for things like bread and milk look dramatically different.
So you pick the base year that makes inflation look low or high, depending on your goal.
Pretty much. He also touches on the difference between arithmetic and geometric averages when calculating indices, which can also subtly shift the results.
And he makes the point that even academics aren't immune. Right. They might subconsciously choose methods that favor their hypothesis.
It's a reminder that bias can creep in everywhere, even unintentionally. Statisticulation isn't always conscious evil. Sometimes it's just motivated reasoning finding the numbers to back it up.
So statisticulation is the umbrella term for all these techniques used to bend statistics to a desired conclusion.
That's a good way to put it.
Okay, so we've seen the trends. Now, the crucial final part. How to talk back to a statistic. How do we defend ourselves?
This is where Huff empowers the reader. It's about developing a critical mindset, not just passively accepting numbers. He suggests 5 key questions.
Question 1.
Who says so? Always look at the source. Is it someone with a known bias, an agenda, a product to sell? Who says so helps you spot potential self-interest or slant.
Makes sense. A tobacco company study on smoking probably needs extra scrutiny.
You think, yeah.
Ah.
Okay, question 2. How does he know?
This is about the method, right? Right, the sample, how data was collected.
Yeah, exactly. Was the sample large enough? Was it representative or biased? Was it a good experiment or just anecdotes? Is the evidence actually solid?
Like we discussed with the small samples and flawed polls.
Right. Question 3, what's missing?
Looking for the context, the comparisons, the data they didn't show us.
Precisely. Are they only giving you percentages without the raw numbers? Are they comparing things that aren't really comparable? Is crucial information being left out that would change the picture? Like that survey on British bathing habits, he mentioned lots of missing context.
Okay. Question 4.
Did somebody change the subject? Is the statistic presented actually relevant to the conclusion being drawn?
Like the semi-attached figure. Using a germ-killing stat to sell cold medicine.
Exactly. Or using a stat about one specific crime type dropping to claim overall crime is down when maybe other crimes went up. Make sure the proof actually matches the claim.
Good one. And the 5th question.
Does it make sense? This is sort of a final reality check. Is the conclusion plausible? Or does it seem absurd?
Like extrapolating a trend indefinitely. Mark Twain and the Mississippi River shrinking.
Exactly. If you project a trend line far enough, you often get ridiculous results. Does the conclusion pass the common sense test? Sometimes statistics are technically correct, but practically meaningless or misleading.
So, who says so? How do they know? What's missing? Did they change the subject? Does it make sense?
Those 5 questions are your basic toolkit for talking back to a statistic.
It's really about not taking numbers at face value. It's about engaging critically.
Absolutely. Huff's goal wasn't to make people cynical about all statistics. They're incredibly useful tools. His goal was to make people aware of how they can be misused.
So we can become more discerning consumers of information.
Exactly. Understanding these pitfalls makes you much less likely to be fooled.
So, hopefully after this deep dive, when folks encounter a stat that seems a bit too convenient or maybe overly alarming,
They'll pause, put on that critical thinking cap, and run through those questions.
it's definitely a valuable skill to cultivate.
And really, this look at how to lie with statistics is just scratching the surface. Becoming truly statistically literate is an ongoing process.
For sure. Well, on that note, maybe a final thought to leave people with. In this world just drowning in data, being able to tell the difference between a genuine insight and statistical manipulation isn't just nice to have.
No, it's pretty much essential, isn't it, for making good choices, for understanding what's really going on around us.
Couldn't agree more. Thanks for joining us for this deep dive.